Linear inequalities. Example, 3x minus 2y less than or equal to 6. First, we have to review the symbols. So if you have less than or greater than, you will have a symbol of dotted line. And if you have like less than or equal to or greater than or equal to, that should be a solid line for the graph. Okay, first we have to isolate our y so we can easily graph the inequality. So isolating our y here, we have to move our 3x to the left side. So we have negative 2y less than or equal to negative 3x plus y plus 6. Again, it's negative 3x plus 6. And then we have to eliminate our negative 2 here by dividing negative 2 to all of them. And the rule in dividing a negative when you're using inequality, this is similar to when you multiply also a negative number. So you will reverse the symbol. Instead of less than or equal to, you reverse that, it should be greater than or equal to. And then negative 3 divided by negative 2, it's a positive 3 over 2x, which is our slope in this case, and minus 3 here. Okay, so treat the whole inequality as an equation so you can plot the graph. So here 3 over 2 is our m, that's our slope, and negative 3 is our y-intercept. So that's from the previous slope formulas that we had. Okay, so let's make a graph. So y-axis is the vertical axis, and we have our horizontal axis as our x-axis here. And then negative 3, that should be 1, 2, 3 down. Negative 3 is here. So that's our first point. Which is our y-intercept. And then our slope is 3 over 2. So 3, that's a positive. So you have to go up 3 units, and that's the rise over run. Run is 2. So 2 units to the right. Okay, so 3 here again is our rise, and 2 is our run. So from the y-intercept, which is negative 3, you have to move up 3 units because that's a positive 3. 1, 2, 3, you're at the point of origin, and our run is 2, move 2 units to the right. 1, 2, so 2 is here. So our point would be at 2. So that's 3 rise and 2 run. And then we can draw the line now. And our line that we're about to draw is this solid line. since we're using greater than or equal to. So it should be passing through the point. Okay, and then in linear inequality, we have to shade the solution. So there are two sides of the line here, the upper part of the line and the bottom part. So since you're using greater than or equal to, it should be the upper part that we have to shade. So we're shading the upper part here. So that would be our solution. Okay, so whatever point inside the shaded region, that's the upper part, it's the solution for this linear inequality. So it means you have plenty of solutions for this example. Okay, next example. X plus 4y greater than 4. So we have to isolate our y here. So we have 4y greater than, moving x from left to right, it becomes a negative x plus 4. Then we divide 4 on all of them. So we have y. Since we're dividing positive 4, so we will not reverse the greater than or the symbol. So it remains here greater than negative 1/4 x plus 1. And then we can label this. This part here is our m, negative 1/4, plus 1 here is our y-intercept. Okay, so and then we graph to find the solution of this linear inequality. So we have the x-axis as horizontal axis and y-axis as the vertical axis. The intersection point is the point of origin, which is at 0, 0. So positive 1 should be over here. 1, 2, 3. So positive 1 should be here. And that would be our y-intercept, which is our first point. And then our rise here, it's negative 1, so we're going down. Our run for the slope, it's 4. So we have to go down 1 unit and then move 4 units to the right. So we will have now 1, 2, 3, 4. So 4. Again, negative 1 means going down 1 unit, and 4 is a positive, so we have to move to the right 4 units. And we mark the second point, which is at 4. And then we connect the 2 points. Since we're using greater than, it should be a dotted line. So it's a broken line passing through the 2 points. So that should be the line. And here using greater than, it means it's going to be the upper part of the line that should be shaded. Again, you will know this as long as you isolate your y. So where to shade? So the upper part would be the shaded part, which is the solution of the linear inequality. If your linear inequality, the y is not isolated, you can actually use test points. So when you test any points along this shaded region, you will get a true statement. Otherwise, your solution should be on the other side. So if you'll get a false statement, so you have to shade on the other side of the line. So that's by using test point. So, but here, what we're using is isolating our y. So if you isolate your y, you will know exactly where's the location of your solution, because it says greater than, so that should be all the values of y is greater than. So we shaded the upper part, and this part here is our solution. Same with the first example, and that's linear inequalities.